everyone, welcome to Unacademy, India's largest online learning platform, which is helping the students to be more successful in their life through this platform called Unacademy. The exams of the most awaited day GATE has finished for 3 branches, which contains analog electronics in all 3 branches. It may be an instrumentation and the exam of electrical students and electronic students. All the 3 branches GATE examination is finished on Saturday and Sunday. On Saturday, instrumentation was completed. Sunday, yesterday, other 2 branches has completed. And I'm coming with the solutions of analog electronics. Every day, 1 branch. So to differentiate, even for future purposes, I want to make separate videos for separate branches. Instrumentation separate, EE separate, electronics and communication is separate. The intention behind this is you will have different papers, different branches, different difficult levels. If you see the analog electronics paper for instrumentation, it was a bit easier than the remaining 2, right? And percentage of questions here is 5 questions were asked in the instrumentation branch, whereas in electronics they asked more questions. I mean more marks. I should say they asked more marks, whereas in EE they have asked only 4 questions, right? So different branches will have different marks, so and different difficulty levels. That is the reason why I'm making a different video for all the branches. Each day one paper I'm trying to do, but it will be useful for all the branches because same kind of questions may be asked in the coming 2022 exam or 2023 exam. So those who are preparing for GATE 2022 and 2023, this video will be very much useful. Video will be very much useful. Okay. Yeah. So myself is Shravan Kumar. I have a master's degree from JNQH in VLSI system design. I have 10 plus years of teaching experience, and then I can handle the subjects like EDC, analog electronics, digital electronics, and DMFT. Right? I have a special code for all you guys, that is SVS10, so which will give you 10% discount on Unacademy Plus subscription. So what do you mean by Unacademy Plus subscription is the students who will get this plus subscription will have a live classes access, and then they can attend all the crash courses. They can write a weekly test. They will be having every 4th hour is going to be a doubt solving session, and the sessions will be in English and Hindi, right? You have something called a rank improvement batch, which is very much useful, right? And then we have something called iconic subscription. So this iconic subscription will have extra benefits of personal coach and a study planner, study booster sessions, and a personalized test analysis, and then preparatory study material will be available for all you guys. Okay. The fee structure for GATE plus subscription is going to be 27,225 rupees after applying 10% discount on each of them. So remember, this 10% discount is going to be finished soon. So we'll be jumping into 5%. So those who want to register, they can register very quickly as early as possible. For 18 months, it is a different structure, 34,000. For 24 months, it is going to be almost 40,000. And for iconic subscription, for 12 months, it is going to be 45,000. And for 24 months, it is going to be 66,600. So how to do it is simply download Unacademy app, get install it, and select your goal GATE ESE, and click on plus subscription, then click on get subscription, and select your own subscription months, and then don't forget to mention this SVS code and click on apply, then you will be taken to, you will be given the 10% off, and then you will be given to, you will be choose, you will be taken to the payment method. So you can apply a debit card, EMI, UPI, wallets, net banking, whatever you want, you can apply. Okay, right? So this is the new batch which we have started on the 1st of February. Um, just one week back we have started this. So this is called Evolve Targeting Gate 2022. Because as 2021 is completed, so Targeting Gate 2022 fourth batch is started, and you can use my code SVS10 to get 10% discount. Okay, so these are the different faculty members of Unacademy, and so this is same thing happened for ECE also. So you can use same code SVS10. You can use same code SVS10 to get 10% discount on it. And this is for 2023, 2 years from now. Start early, drive slowly, reach safely is the motto. So if you start very early, you can reach the goal very quickly. So because of that, we started this course. Ascent batch, fourth batch started on 1st of February. So you can use the code SVS10. You can use the code SVS10. Okay. Then this is also for ECE. So this is also started on 1st of February. Okay, right? So you all guys can follow me on Unacademy using this. Okay, now we'll start discussion. So let's say this is problem number 1. So this is all memory based. The question paper is not yet released by IIT Bombay. We are waiting for still IIT Bombay to get the questions, but this is all simply memory based. This is all the memory based. Why I'm saying memory based is simply the students who are coming out of the examination have told us this is the question. So based on their reply, their feedback and their information, we are doing this analysis of the paper, right? The first question is, sir, so the difficulty level of this question paper is not so difficult. So most of the problems we have discussed almost in our analog electronics classes, right? So the difficulty level is not much. So now if you look at this problem, consider the analog circuit shown below where V0 is equal to 5 volts. He says V0 is equal to 5 volts. V0 is equal to 5 volts. Assume that the op amp is ideal, okay? Then what is the value of the load resistance RL? He's asking what is the value of this resistance RL? What is the value of the resistance RL, right? So from the given, he says op amp is an ideal op amp. Whenever op amp is an ideal op amp, so we know that the open loop gain is infinity, and you can see whether the negative feedback is available or not. Negative feedback is available. Yes, sir, there's a negative feedback. Negative feedback is also there. Both negative and positive feedback is there, but we can also have the negative feedback. So negative feedback is must, whether positive feedback is existing or not. So negative feedback is must, and then we should also see what is the output range. So anyway, generally this is going to be minus VSAT to plus VSAT. So these are the three conditions which must be satisfied by the op amp. So whenever this op amp open loop gain is infinity, so whenever the open loop gain is infinity means, what do you mean by open loop gain is infinity, sir? So it means, so V output is equal to open loop gain into the VID, generally we call. What is VID, sir? The difference of the input voltages, this V plus and V minus. V plus and V minus. Whenever this open loop AOL is infinity, so what you will get is VID is going to be V0 by A naught L. That is, so V0 by infinity. Whenever V0 by infinity is there, so VID, the difference of voltages, is going to be 0. It means, so from this what I can say here is the assumption is going to be V positive voltage, that is non-inverting terminal voltage must be equal to the inverting terminal voltage. Okay, So this is very important. This is very important. Non-inverting terminal voltage is equal to inverting terminal voltage. Now assume that this is some voltage. This is some V minus, or for my convenience I'm saying this is going to be VA, and for here I'll say this is going to be VA and VB, right? So if I can able to find out, the voltage at VA, I can easily find out the voltage at VB. If I can able to find out the voltage VB, I can calculate the value of the load resistance RL, because once I know the value of the voltage which is coming here, similarly I can find out what is the current flowing through it. It means if I can apply a KCL at this point, if I can apply a KCL at this point, I can easily find out what the load resistance value RL. Yes or no, sir? Very easy, very easy. This kind of problem we have discussed, sir. As I told you many times, 99% of times, you don't need extra knowledge of any other concept than KCL and KVL to solve analog electronics. Analog electronics. Frankly speaking, analog electronics is easier. But as the feedback which I am getting from ECE, it was bit mix of some other concepts of network theory also there. But for an instrumentation students, it was very clear. He did not get into any other subjects. He did not add anything. He has given purely op-amp problems. He has given purely op-amp problems. That is the best thing which happened actually. That is the best thing which happened. So let's try to start this. So apply KCL at point A. Apply KCL at apply KCL at node A. Okay, so I assume that the voltage at the node A is going to be VA. So can I write VA minus 0 by 10K plus VA minus V naught by VA minus V naught by 10K, VA minus V naught by 10K is equal to 0, right? So this 10K and this 10K will get cancelled, because even if you take common, so the 10K will go away. So what will be remaining, sir? You will be having VA plus VA plus VA plus VA minus V naught is equal to 0. So what I can write is going to be V naught is equal to 2 times of RAR. Why should I write V naught is equal to? Okay. 2VA is equal to V naught. So VA is going to be V naught by 2. Why I am writing VA is equal to V naught by 2, sir? Because in the given problem, he has mentioned the value of the V naught very clearly. If you look at here, he has mentioned that the value of V naught is 5 volts. V naught is going to be 5 volts. When V naught is going to be 5 volts, now you just substitute the value of V naught here. So VA is going to be 5 by 2. So I can say this is going to be 2.5 volts. So VA is equal to 2.5 volts is what we get, right? So now, according to the previous discussion, or according to the concept of virtual ground, according to the concept of virtual ground, according to virtual ground concept, according to virtual ground concept, VB is also equal to VA. That is, indirectly, V positive must be equal to V negative. Yes or no? So I can also say VB is also 2.5 volts. VB is also 2.5 volts. Now we'll try to apply the KCL at node B. Now try to apply KCL at node B. Apply KCL at node B. If you apply the KCL at node B, Now what you'll get, sir, just go back and see. So this is going to be VB minus 1 by 5K, VB minus 1 by 5K plus VB minus, so if you look at this unknown value of the load resistance RL, is going to be VB minus 0 by RL, VB minus 0 by RL, unknown value RL, plus VB minus, you have one more current which is coming from this. Anyway, this current is going to be 0 and this current is also 0. The input currents which are coming are also 0, that we already know. So this current and this current is 0. Now whenever these two currents are 0, now the whichever current is coming here, VB minus 5 by 10K. So VB minus V0, I should say V0 by 10K is equal to 0, right? So what is the V0 value? If you look at from this, I can simply take out VB. VB also, I know the value of VB. Why should I take out? So anyway, VB is also 2.5. I'll simply write here 2.5 minus 1 by 5K plus VB is also 2.5, 2.5 by RL plus VB is how much, sir? VB is 2.5 minus V0 was given as a 5 by 10K is equal to 0. If you look at this, it's going to be 1.5 by 5K plus 2.5 by RL plus this would be minus 2.5 by 10K is equal to 0. Sir, I'll do one thing. I'll multiply and divide this first term by 2 so that I'll get a very easy one. I mean to say both these RL, this will be getting the same value. Okay. So if you look at that, so it's going to be 3 by 10K minus 2.5 by 10K is equal to plus 2.5 by RL is equal to 0. Okay, if you look at this, what will be remaining? So it's going to be 0.5 by 10K plus 2.5 by RL is equal to 0. So if you look at here, what I'll do is 2.5 by RL is equal to minus 1 by 20 KL, right? While 1 by 20 KL, right? So what will be remaining, sir? So RL is going to be did I do some mistake here? Anywhere, somewhere? I think in the given problem, this is also 10K. I think this is also 10K. So if that is the case, we'll get very easily. So this is also 10K. So then I need not do this multiplication part. If this is also 10K, just a second. I'll do one thing. Just a second. This part is not required. So this, I think this is the mistake which I have done. So probably I haven't seen that properly. Because these are all memory based problems. That is the reason why I got that. This is going to be 10K. This is also 10K. Then this is also 10K. If that is the case, we'll get it very easily. Then what will be remaining, sir? So this is going to be minus 1 by 10k is plus 2.5 by RL is equal to 0. So 2.5 by RL is equal to 1 by 10k. So RL is going to be 2.5 into 10k. So the final value is RL is equal to 25 kilo ohms. The load resistance RL value is going to be 25 kilo ohms. Or load resistance RL value is going to be 25 kilo ohms is the final answer. Are you getting the point or not? So the unknown value of the load resistance is going to be here. It's going to be 25. Simply you should write 25. Kilo ohms is already mentioned. So when you mention kilo ohms, you will not write it again. So our answer is going to be 25 25k. Okay. Now shall we go to the next problem? As I told you, all these problems are very easy problems. So problem number 2. He was simply asking about the output voltage. I think we have done same kind of problem in our previous discussions also. If you go back and see my previous crash course, analog crash course, we have discussed the same kind of problems. Okay. We have discussed the same kind of problems. Okay. So he has given a 50 millivolts here, and then I'll do one thing here. It's a very simple problem only. He's asking about V naught. So assume that this voltage is some Vx, and this voltage as a Vy. I know. Whenever he did not mention here, this is the voltage 50 millivolts. Same Vx is going to 50 millivolts. 50 millivolts only. Just for my convenience, and I'm assuming this Vx. I'm assuming this as a Vx so that I'll get the final value of Vy. Right? So V naught. So for that case, first let us try to apply KVL at node X. I should mention node X so that it is going to be Vx. So what is this here? It's going to be Vx minus 0 by 12k. 12 I'll write 12k. Vx minus 0 by 12k plus Vx minus Vy by 10 kilo ohms. Vx minus Vy by 10k is equal to 0. Right? So it means it would be Vx by 12k plus Vx by 10k minus Vy by 10k is equal to 0. So if all k's are gone out, so what I can write simply, Vx is going to be 1 by 12 plus 1 by 10. I'll put this as a Vy by 10 simply for my convenience. Okay, and then what it will be, sir? It's a very simple problem. This is going to be Vx into 12 plus 10 by 120 is equal to Vy by 10. So this and this will get cancelled. So Vy is going to be 22 by 12 into Vx. So it is going to be 11 by 6 into Vx. So I can call this as going to be 11 by 6 into, how much is the Vx, sir? Shall I say now from, I'll do one thing here. I'll just remove this. After this, what I'll make a statement here from virtual ground concept. From the concept of virtual ground, from the concept of virtual ground, Vx is equal to 50 millivolts. If you go back and see, here the input given is 50 millivolts. The input is given as 50 millivolts. So from this concept of virtual ground, now what is Vy? Vy is going to be 11 by 6 into 50 millivolts. 50 millivolts. So you can see here this is going to be 1150 by 6. Assume this is, oh, if you want to simplify, you can simplify here. It's going to be uh, just a second. I'll do one thing here. I have to use some other pen. So 2 3s are and 2 25s, right? 2 3s are 6, 2 25s. So 25, 25, 275 millivolts by no, 25 into 11 we need to mention. How much is going to be 25 into 11, sir? 25 into 11. You can find out this simply. I'll do from my mobile. So just wait a second. Just wait a second, sir. I'll do it because I have to do it. I can't simply sit like you. So 11 into 25 divided by 3 is going to be 91 points, or otherwise simply you put it 275 by 3 because we don't know what is going to happen in the next case. So 275 by 3 millivolts, you put it like this, Vy. So next apply KCL at node Y. Node Y. So this is very simple problem. We have done many problems like this. Go back now and apply here. This is going to be Vy minus Vx by 10k. Vy minus Vx by 10k plus Vy minus 0 by 1 kilo ohm is going to be 1k plus Vy minus V0 by Vy minus V0 by 10k, okay, 10k is equal to 0. Vy minus 10k is equal to 0. So simply, so what I try to do is, anyway, we have to find out the V0. Yes or no? V0. So for that case, what I'll try to do is, simply what I'll do here is, I'll keep this Vy by 10. Okay, can I put this as a 10 Vy by 10k? Yeah, this I can do it, right? So again here I need to put Vy by 10k minus Vx by 10k minus V0 by 10k. Why I am doing all these things, sir? Why I am doing? Because everything will go away. So what we get is 12 Vy minus Vx minus V0 is equal to 0. So if you simply simplify, so V0 is going to be what, sir? 12 Vy minus Vx. So how much is the Vy? Just now we have calculated. Vy is going to be 275 by 3 millivolts. I'll put this as a 275 into 10 to the power of minus 3 by 3. How much is the Vx? Vx is as same as that of this 50 millivolts. Yeah, I'll put this as the 50 millivolts. This is going to be 50 millivolts. So if you calculate that, this is going to be 3 ones or 3 fours. So if you calculate this, 4 into 275, I'll do it here. 4 into 275, 1100 is going to be 1100 millivolts minus 50 millivolts. So it is coming around 1050 millivolts If you want, see, now we'll see in millivolts. He asked in volts only. He did not ask us in millivolts. Though we are getting the answer in millivolts, but he is asking us to put it in the volts. So it's very simple, approximate value. So V naught, not actually it is the exact value. It's going to be 1.05 volts is the right answer. This is the easy problem which he was asked. So V naught is going to be 1.05 volts. 1.05 volts is what he asked. Okay. So this is the answer 1.05. The result is not out, but still. So as per my knowledge, this V naught should be 1.05. Hope many of you have done the answer very correctly. As per my knowledge, because this is simple problem only. Simple problem only. You would have done very well in this. Okay. Now we'll see the next problem. Problem number 3. So as I told you, this is all memory based. Sometimes the question I have changed. So Vi is going to be 0.4 sine omega t. 0.4 sine omega t. Consider the analog circuit shown below, where diode has voltage drop of 0.6 volts. He says this is going to be 0.6 volts. 0.6 volts. When it gets forward biased, okay, the value of VA in volts is asking about the voltage here. Sir is not asking about the output voltage here. Remember that point. He is not asking this V naught. He is asking this VA. Remember that point. He is asking the voltage at this point A, not at output voltage. When the input is maximum, so what is the input he has given? He has very clearly given that the input is a 0.4 sine omega t. 0.4 sine omega t. So if it is 0.4 sine omega t, means you'll get an input like this. You have an input of 0.4, and then this is the peak to peak value. Is going to be, he mentioned this is going to be 0.4 sine omega t. Whenever this is going to be 0.4 sine omega t, is going to be 0.4 and minus 0.4. So for this case is asking us to find out what is the voltage at VA. Right? Right? Now assume that the diode is off. Sir, whenever initially the diode is off, now what happens, sir? Whenever the diode is off, this VA voltage you don't know. The V naught is going to be what, sir? V naught is going to be directly connected here. So V naught is connected. I'm sorry. V naught is connected here. So the output is going to be 0 only. Output is going to be 0 if it is a reverse bias, if the diode is reverse bias. This happens when, sir? Whenever your input voltage, this voltage is less than the 0.6 volts. That will happen whenever this minus volt is higher. It means for any value which is less than 0 volts. So if you are applying a negative voltage, then what happens? So this is, let's say this is going to be 0 volts. This is going to be 0 volts. If this is a reverse bias, this is 0 volts and this is also 0 volts. For any voltage which is less than 0 volts, this op amp's output will be minus Vsat. If that is the minus Vsat, so this is diode is going to be 0. But he asked us to calculate at 0.4 volts, which is greater than the 0 volts, right? Which is greater than 0 volts. It means we need to find out very easily what would be the output voltage. If we can be able to calculate what is the V output voltage, whenever this is going to be forward biased. So, sir, I don't think I need any extra explanation for this. Very simple problem, direct problem, right? So now you can see here very simply. Now this VA is going to be the voltage drop across the diode and then V naught. Assume that this voltage is going to be across the load resistance RL. Nothing wrong, right? This is plus minus. This is going to be plus minus. So if we apply a KVL here, I can simply write VA is equal to the voltage across the diode and the V naught. Right? We already know he has officially given from the given problem, this VA is going to be 0.6 volts, 0.6 volts, but I need to find out what is the V naught. What is the V naught? So here comes the problem. Here comes the problem. So how will you calculate this problem? Very simple, sir. So from the concept of virtual ground, or from the concept of from the concept of from the concept of virtual ground, from the concept of virtual ground, from the concept of virtual ground, V naught is the output voltage. From the concept of virtual ground, just wait a second. We know that the positive voltage must be equal to negative voltage. Sir, at positive peak means at positive peak, at positive peak, at positive peak, at positive peak, V plus is going to be how much, sir? Very simple. What is the positive peak value? Is going to be 0.4 volts. So when it is 0.4 volts, you will get 0.4 volts only. 0.4 volts only. So whenever this is 0.4 volts, yeah, whenever this is V plus is 0.5 volts. Now what V plus must be equal to V minus is going to be 0.4 volts. Now if you go back and see, so whatever the voltage which you are having here, this is a V minus, this is as same as that of V naught, as same as that of V naught, as same as that of V naught, right? So what is that V naught? Now V negative is equal to V naught is equal to 0.4 volts, 0.4 volts. Now simply you can write here VA is equal to 0.6 volts plus 0.4 volts. So VA is directly equal to 1 volt. Very simple problem he asked. Very simple problem here. You don't need actually this much explanation. In the examination, you can simply identify. You can simply identify what is the answer. You don't need much knowledge. You don't need much knowledge to answer this question. This is very simple. It is very simple. It is very simple problem. This is very simple problem only. Okay. Now this is problem number 4. This is the problem number 4. He has given collector current IC. This assume that is going to be some current. So he is asking for I04 here. And he has given some interestingly beta. Sir, whenever beta is, sir, here he did not mention beta is large. Sir, we have seen many problems. We have seen this is the simple concept of current mirror actually. Almost current mirror, equal to almost current mirror. But he has given, people think that current mirror, direct current mirror, but it is not the current mirror, sir. It is not the current mirror problem. He says this is going to be, beta is going to be 20. It is not the higher value. Whenever beta is going to be 20, don't think that this IB is going to be 0. So IB is going to be 0, right? Now here you can see you have some collector current IC is flowing, right? Assume that this is going to be transistor number Q1. If this transistor is going to be Q1, this transistor is going to be Q1. Assume that the collector current is going to be I1. So this is going to be some Ib1. Ib1. If you look at here, four transistors are in parallel actually. So how many currents will flow here? 1, 2, 3, 4. So can I say this is going to be 4 Ib1, 4 Ib. I can say IB for IB. So if you want to mention this, you can mention this also, Ib1 or IB. So how many currents are flowing here? Totally 5 base currents are there. Totally 5 base transistors, five base currents are flowing, and one collector current is flowing. So this 1.25 milliamps, 1.25 milliamps current is equal to collector current IC1 plus IB1, I can say IB plus 4IB, because all the base currents will be same. So can I say this is going to be IC plus 5 times of IB. 5 times of IB is going to be 1.25 milliamps. So whatever the collector current IC is flowing, remember same current is going to be I04. Same current is going to be I04. So if I can able to calculate the value of IC, if I can able to calculate the value of IC, it is easy for me to calculate the value of I mean to say IB. So what I know is IC is equal to, we know that IC is equal to beta times of IB. So IB is equal to, now, can I write this as IC by beta? Now substitute this value, sir. It's going to be 1.25 milliamps is equal to IC plus 5 times of IC by beta. I see. This is also very simple problem. This is also very simple problem which he asked. Very simple problem which he asked. So this is going to be, can I shift both of them here? I will take out IC common. If IC common I have taken, so it's going to be 1 plus 5 by beta. 1 plus 5 by beta is going to be, so 1.25 milliamps. So the collector current IC is equal to 1.25 milliamps by 1 plus 5 by beta. So how much is the beta he has given? How much is the beta he has given? This is going to be 1.25 by 1 plus 5 by, I think beta has given 20, right? Yeah, beta is given 20. So whenever beta is going to be 20, now what I'll get here is, so 5 ones and 5 fours, I'm going to get 1 by 4. So 1.25 by 1 plus 1 by 4 milliamps. So if I write this 1 by 4 as 0.25, that will help me a lot. So IC is going to be 1.25 milliamps by, I'm writing this 1 by 4 as 0.25 so that you can see numerator and denominator will be equal. So I can write IC is going to be 1.25 milliamps by 1.25. So what will be the remaining, sir? If you can see, I can get IC is going to be 1 milliamp. So if one current IC is going to be 1 milliamp, so from what I know, sir, that IC1 is equal to IC2 is equal to IC3 is equal to IC4 is equal to IC5, whatever, right? Or I can say this is going to be I01 is equal to I02 is equal to I03 is equal to I04. So whatever I'm getting this, so I generalize this here. So IC1 is equal to I04 is equal to IC. So what is I04, sir? I04 is 1 milliamp, which is the easiest answer which you got. Sir. Okay, so this is not the problem of beta is large. This is not the problem of beta large. This is not the problem of beta is equal to very large. When beta is equal to very large, your IB is going to be directly 0. If your IB is directly going to be 0, so what collector current you are going to get? So if that is the case, if beta is very large, this base current IB is going to be 0. All the base currents are going to be 0. So this 1.25 milliamp same current is going to be following this IC1, so correct current mirror, so this I04 is also 1.25 milliamps, but this is not the case of IB. Beta is very high. Beta is the value which is equal to 20 only. Beta is equal to 20 only. Beta is equal to 20 only. So be careful about this. So to confuse you, he has given the value of beta only. So don't consider this problem as the problem of a beta large value. So it is like, you know, beta large. If you think the beta large is given, so that will be a problem, right? So don't think that all the time IB is going to be 0, right? Generally, in case of current mirror, what will get, sir? IB is he will clearly mention that beta is very large. If the beta is very large, we can think that it is going to be IB is going to be 0. Whenever IB is going to be 0, what will get, sir? We'll get IC1 is same as that of 1.25 milliamps. So direct answer will get directly going to be 1 I04, that is collector current of the fourth transistor will also be same as that IC collector current of the transistor Q1. Then what you will directly get is going to be 1.25 milliamps. But this is not the case of that what you are thinking. This is something different. Okay. Okay. Good. So shall we go to the next problem? I think this is the last problem. This is the last problem which he asked. This is the last problem which he asked. Question number 5. Question number 5 he asked. Transistor Q1 has a beta of beta 1 as a 99. So if that is the case, this is the transistor beta 1. Okay. And a Q2 has the beta of 49. The current Ib2 is asking about this Ib2. He's asking about the, sir, this is, if you remember, what is this circuit, sir? What is this circuit? Two collector currents are tied together, and emitter of one transistor is connected to the base of the another transistor. So if you recollect concepts, this is going to be Darlington pair. Darlington pair. Very simple problem. This is also a very simple problem. So if you look at here, this is going to be, I can call this as IE1, and I will call this as IC1, and I can call this as IB1, and this is going to be IE2, IB2, and this is going to be IC2. What is asking, sir? Actually, is asking for IB2. Okay, so from this given diagram, what I can say is, can I say IE2 is equal to IB1? IE2 is equal to IB1. This you need to remember. So if you remember this, we'll proceed to the problem, right? So first of all, I need to calculate IB1 so that I can say something. I can call about this IE2. So from the IE2, I can calculate IB2. So how we calculate the base current Ib1? Similarly, you will calculate the base current Ib2 if you know the value of IE2. But he has already given IE1. He has given the value of IE1. Yes or no? He has given the value of IE1. If you know the value of IE1, now you can easily calculate what is IB1. So what is IB1, sir? IB1, direct question, sir. IB1, base current IB is equal to, we know that actually what is the relationship between base current and emitter current, IE. We know that IE is equal to IB plus IC, standard equation. So this is going to be IB. What is this? IC is nothing but beta times of IB. So what I can write here is going to be 1 plus beta into IB is going to be IE. If you want to calculate the value of IB, we can write it as IE by 1 plus beta. So this is the equation which you guys should remember. You might have practiced this kind of equations many times. So I think I have told you in the while we are discussing the problems also. Okay. So IB is equal to IE by 1 plus beta. IB is equal to IE by 1 plus beta. So what I'm expecting, IB1 is equal to IE1 by 1 plus beta. What is IE1, sir? IE1 from the given problem, it's going to be 50 milliamps. It is going to be 50 milliamps. So it's going to be 50 milliamps. Is going to be 50 milliamps by 1 plus beta is how much? Beta is going to be 99. Beta is going to be 99. Beta is going to be 99. So what I can write is going to be 50 milliamps by 100. If this is 100, I'll get IB1 as a 0. I'll direct to write, sir. I'm going to get this as a 0.5 milliamps. IB1 is going to be 0.5 milliamps is what I'm going to get. If IB1 is going to be 0.5 milliamps, if IB1 is going to be 0.5 milliamps, then now this is same as that of IE2. IE2 is going to be now IB1. So now what he is asking, sir, is asking us to calculate IB2. So can I say IB2 is going to be IE2 by 1 plus beta 2. So here this was beta 1. This was beta 1. Now I am doing it here for beta 2. Beta 2. So IE2 just now we calculated is going to be 0.5 milliamps by 1 plus what was the beta 2? Beta 2 is 49. Beta 2 is 49. So if beta 2 is going to be 49, if beta 2 is going to be 49, so this is the easiest problems which was asked in instrumentation, sir. No much complication here. It's going to be 50 milliamps. So IB2 is going to be 0.001 milliamps. 0.001 milliamps. Now let us see whether he asked us milliamps. 0.05. No, this is 0.01 only, not 001. We get 0.1 only, 0.1 milliamps. 0.1 milliamps. Yeah. This is this kind of small mistakes which every student will do, right? 0.1 milliamps is going to be IB2. Now let us see what he asked. He not asked if he asked in microamperes. So, but as per my knowledge, this was later on it was changed to micro to yeah, it is micro only now, not milli. It was asked in microamperes. Microamperes. If he's asking in microamperes, if he's asked in microamperes, so simply I can write this as IB2 is going to be 10 microamperes. 10 microamperes. So your option should be anyway asked microamperes. Just simply put 10. 10 is the answer. 10 is the answer. Okay. 10 is the answer. So these are all the 5 simple questions which were asked in the analog electronics of what I say analog electronics of instrumentation. They are the 5 questions which were asked, right? So very simple questions, direct questions were asked, not much complicated questions. So, but later on, what Triply and EC got are bit difficult problems. I'm not saying they are difficult. They are moderate level when compared with your instrumentation and log electronics, right? So hope this will help the students of 2020 to this session, which I am taking today, will definitely help the students. So after finding the question paper again, complete solutions I'll try to provide. So this is only the memory based questions which I have told you. These are all the memory based, right? Sometimes the questions may be changed. Uh, and we'll see after once IIT Bombay releases the question paper, IIT Bombay releases the question paper, then we'll try to see the new question paper. Okay, new question paper, and I'll try to answer all the questions again based on the IIT question paper. Okay, so all the problems were simple. So I don't know which of them are multiple choice questions or which of them are this thing. So, but the only thing is the first question answer was 25 kilo ohms. The unknown load resistance RL is going to be 25 kilo ohms, and then second question was he asked for V0. V0, I think V0 what I got is going to be 1.05 volts. 1.05 volts, and then the question number three answer was what is the value of the. So remember, he did not ask the value of the V output. Generally, what happens is students will think that V output is answered. So generally write 0.4 volts. So which will give you 0 marks. Remember, he did not ask the value of the V0. He did not ask the value of the V0. He asked the value of VA. He asked the value of VA or some voltage here, VOD kind of thing he will be asking. So in the examination, I think it was clearly mentioned as VOD. VOD, right? Output of the diode voltage kind of thing he asked. So this is what they asked. Third question, and the answer was 1 volt. And the fifth question, so just remember this is the star point. Beta is not 0, beta is not high value, not 500, 1000, 100 or very large. Beta is simply 20. Whenever beta is simply 20, you can apply the concept of BJT, and then you can get the current mirror concept, and directly you can apply the voltage of, current mirror concept, and you can say this I04 is going to be this IC1. So, and then you'll get the value as a, I think 1 milliamp is current you got. Okay. Simple problem. This is also just to make you, and this is a very simple problem. Again, Darlington pair, and they are asking us to calculate Ib2. So Ib2 is what we got is going to be 10 microamperes current, 10 microamperes current, right? So please post your comments if anything wrong is there, so that we can correct it in the next video. Don't think that we are extraordinary people. No, we are also learning like you. So every day is the learners we are, dear students. We are also everyday learners. So please, we are trying to improve ourselves regularly. If there is any problem, any mistake in the question paper, or any mistake in my solution, please post a comment if something wrong is there. Okay, right. Thank you. And we have something called plus subscription. Don't miss this. So this plus subscription will give you you can attend live classes, crash courses, weekly tests, and doubt solving sessions. You can have sessions in English and Hindi. You can have sessions in English and Hindi, and you have something called rank improvement batch. You have something called rank improvement batch. Then you will be having a personal coach, and you will be given a study planner. Will be given a study planner for iconic subscription along with the plus subscription. Extra benefits are going to be a personal coach, study planner, study booster sessions, personalized test analysis, and the preparatory study material will be available. And for 12 months plus subscription, 27,000 change. For 18 months, it's going to be 34,650. And for 24 months, it's going to be 39,600. This is SVS 10. As I told you, this is going to be 10%. Soon we are going to decrease this to 5%, sir. So hurry up in getting it. Please hurry up in getting percentage of off. That 10% to 5% we are going to change. For 12 months iconic subscription, it's going to be 45,000 change. For 24 months, it's going to be 66,600. So please be hurry up, right? So this notes, this solution, I'm going to put it in Unacademy GATE English Telegram channel. So you can also post that any comments there. So on Unacademy Telegram GATE English channel, okay. And we have extra other channels also, Pareeksha, GATE Academy for mechanical engineers, GATE Academy for civil engineers and chemical engineers. We have GATE Academy computer science and instrumentation, sorry, information technology. Unacademy GATE questions we have, electrical junction also we have. So, and the channel which I am teaching here is Unacademy GATE English. So please do subscribe to this and share this with many students who wants to target for GATE 2022 and 2023, sir. So please do like the session. Please do like the session. Please share the session so that it will benefit the students. Please subscribe to the session, and then subscribe to the channel, and then hit the bell icon. Okay. Thank you. We'll catch up tomorrow with the solutions of electrical engineering GATE analog electronics 2021. Okay. Thank you all. Bye. Take care.